Okay, matric. So for reflections of graphs, you really just need to know the basics from your previous grades. So reflections in the x-axis. Okay, when you reflect in the x-axis, it means you're folding downwards. So look at this one here. If you're reflecting it in the x-axis, it's folding downwards, and so where your y's were positive, now your y's are negative. So when you reflect, you make your y negative for x-axis reflection. For reflection in the y-axis, you make your x's negative. All right, so just remember, reflection in x, make y's negative. Reflection in y-axis, make x negative. And then we've already covered the reflection in line y equals x. That's your inverse. You make y an x and x a y. Then, for example, 9, they give you the graph of f of x equals negative 2x plus 8. So it's a straight line graph. And then g of x equals to 3x squared, which is a parabola, a concave up or smiling positive parabola. So it says determine the equation of h, which is the reflection of f in the y-axis. So for y-axis, you're going to make your x negative. So you write your f equation out, and then for h then, instead of x, it's going to be negative x. And then you have negative 2 times negative x is positive 2. So that is the equation of h of x. So reflections in the y-axis make x negative. For reflections for the next one, s is a reflection of g in the x-axis. So for x-axis reflections, you make the y negative. So g of x is y equals negative 3x squared. So for s, you're going to make it negative y equals 3x squared. But we never leave an equation of a graph as a negative y. So we just take the y to the other side. So it becomes y equals negative 3x squared. And that's your reflection in the x-axis. Then for question or example 10, it says the graph of f of x equals a to the power of x. So it's an exponential. Passes through the point negative 2 and 25. G is a reflection in the line x equals 0. That means it's the y-axis that it is reflected in. So our x's have become negative. So let's just highlight these. So our f of x is this one. And the g of x is that one. Okay, so f of x is a decreasing exponential graph. And if you looked at the previous videos, a decreasing exponential graph means that the base is between 0 and 1. So it's a fraction. So the base is a fraction. So whatever the a value is, it's going to be between 0 and 1 for a decreasing exponential. How do I know it's decreasing? It's going down from left to right. So for question A, you are trying to find the value of that base, that A. So you have been given a point. So I'm going to, on the next slide, it's the working out. So we're going to go on to the working out for A. And then it says if g of x equals b to the power of x, determine b. So g of x is a reflection. The green one is a reflection of the yellow one. And then for c, it says determine the coordinates of p prime with that little line. It's the image, the mirror image, or the reflection of p that exists on g. And then if h is a reflection in the line y equals x, so the inverse, we need to determine the equation of the inverse, and then the coordinates of p double prime or second prime, and that means that where p has been reflected along that line y equals x. Okay, so on the next slide, it's going to have all the answers up. We're going to work through. All right, so for question A, we have to find the value of that base in the equation y equals a to the power of x. So when we're working with f of x equals a to the power of x, please write it in the form y equals a to the x. And then you see you've got 3 letters there. two of which are X's and Y's. So we then subs in a point when you have three letters, two of which are X and Y, subs in a point. So they have subs then over here. You can see the point -2 and 25. So remember, a to the power of -2 is the same as 1 over a squared. And so all they've done is they've just flipped both, because that's 25 over 1. So they've just flipped both fractions so that you have a squared by itself. And then you are going to square root, and remember you need a plus minus for the square root. But very importantly, the base of an exponential is always positive. So we must have the positive base. Remember I said it's between 0 and 1. So we need positive 1/5. Then for question B, they said we must reflect f of x in the line x equals 0, the y-axis. And that gets us g of x, which has the b in it. So we're going to try to find b. So some of you will be able to just realize, okay, well, if it's reflecting in the y-axis, it's becoming a positive increasing exponential, so it must have a value of the base as greater than 1. And then you can go straight to looking at the answer of 5. But the idea of reflecting in the y-axis means that our x becomes negative. So in our f of x, we had a fifth to the power of 5. And so now we'd have, a fifth to the power of x. So then we'd have a fifth to the power of negative x if we reflect in the y-axis. Now, negative x is the same as -1 times x. And a fifth to the power of -1 is the same as 5. So the base of the new graph is 5. They're reflected in the y-axis. It's been folded over the y-axis. Please just look at the mark allocations. If it's for 1 mark, you can go straight to the answer. If it's for 2, 3, 4 marks, we need to see more work. Then for question C, they want to know what is the coordinate of P prime, in other words, the new point P on the new reflected g of x graph. And so remember, when we are reflecting the y-axis, we are changing the x-coordinate sign. So it was -2 and 25, so now it's just going to be +2 and 25, because it's just your x value that will change sign, not the y value for a y-axis reflection. Then for question D, we have to find the inverse equation. So the original equation is y equals a fifth to the power of x. Now, if you got that wrong, we'd still carry over the mark. So please carry on with the process. So remember, for inverse, the first step is to make y's x's and x y's. Do the swap. Then algebraically rearrange. You need to get y by itself. It's an exponent, so you have to change to log form. You must know after all these videos that the inverse of an exponential graph is a log graph. So you have to get log in your equation. So we have x equals a fifth to the power of y. So the fifth is your base, so you have to then keep it the base of the log, make it small. And then the fifth had the y, so now the y goes away and the x gets a turn to sit with the fifth. All right, and that's how we write it out, and they wanted it h of x. So then they want the coordinates of point P with the situation. Now remember, if you're reflecting the line y equals x, you are swapping the y coordinates. So P double prime or P prime, P second prime, you're just swapping the x and y. So the original P was -2 and 25. So the new one on the inverse is 25 and -2. And that's it. That's how difficult it is. All right. When moving on now, we are looking at the interpretation of graphs. So again, this is coming back from grade 11 functions, as well as using a little bit of this new stuff. But it's mainly skills learned in grade 11 and a little bit in grade 10. Okay, so there has to be some revision that you do on grade 11 functions. So for example, 11, it says, the sketch alongside shows the graph of f of x equals log base b x, and then you've got f -1 g given, and then the reflection of f -1 in the x-axis is G. All right, then 8 and 3/2 is a point on F. Now, you can see the red points I've already put onto the graph. That's just from the later questions. I've just got them there just to keep them. We'll refer to them in question F. All right, so question A says, determine the value of B. So B is that base of the log. So remember, you need to rewrite the equation. Instead of f of x, you've got to write it as y equals to log base bx, and then realize that you've got a y and an x and a b. Forget about the log. The log is a process. So we are talking about the y, the b, and the x. So you've got 3 letters, 2 of which are x and a y. So you're going to subs in a point, and the point they've given you is 8 and 3/2. So we're going to subs that in. Then once you've subs it in, you're going to have to get the base by itself and be able to work with it. So we want to get rid of the log. So we're going to put it back into exponential. So the base of the log becomes the base of the exponent. And then the b had the 8. So now the 8 goes by itself. And the 3/2 joins the b. So it's just whatever's with the base switches around depending on the form you're in. Right. And then now you can solve for b. So here you have to use your idea of rational exponents from grade 11. So we have b to the power of 3/2 is equal to 8. Now, in order to get b by itself, we're going to multiply by its inverse. But then we've got to do it to the other side as well. Don't forget, you've always got to make sure whatever you do to one side of an equation, you do to the other to balance it mathematically. So these fractions cancel out, and so you're left with b to the power of 1, and then 8 is 2 to the power of 3. Then these 3's cancel, and you're left with 2 squared, which is 4. All right, so these are in the notes that were posted on the Google Classroom. Then for b, they're asking us to determine the equation of f negative 1. F negative 1 is your inverse. So you start with your f. You now have your base, please. You're not allowed to use the b anymore. You've got to use the number. Even if you think your number's wrong, you use your answer from the previous question. So you write it out as y equals log 4x, and then the first thing you do is your switch of x and y. Then once you've switched x and y, you rearrange it algebraically to get y by itself. So because y is sitting with the base at the moment, to get it away, we've got to keep the base and bring the x as an exponent. So then just remember always, if you have a log graph, the inverse is an exponential and vice versa. Then for question C, determine the equation of G. G is the reflection of f negative 1, the inverse in the x-axis. So here's your f negative 1. If we're in the x-axis, it means our y value is becoming negative. So instead of f negative 1 being y equals 4 to the x, our g of x is negative y equals 4 to the x. And remember, we don't want y as negative, so we bring the negative across. So g of x is the reflection in the x-axis. Then for D, write down the domain of f. So here's f. Right. And again, you can see it's just not touching there. It's very slightly almost blurred, but it's not touching its asymptote. So f, you cannot let it touch this asymptote. So that is when x is equal to 0. But then after that, it doesn't matter what it touches as long as it's greater than 0. So that's why x is greater than 0. Can't equal 0 because 0 is your asymptote. Okay, so remember x equals 0, or your y-axis is your asymptote. And you can also use your bracket notation if you want. Right, then for E. E says write down the range of f negative 1 and then the range of G. So let's look at f negative 1, your inverse graph. So remember, if your original asymptote was a y-axis, it means the inverse is going to be the x-axis. So it means that our graph can't touch the x-axis, so the y values are going to start at 0 and move their way up to infinity, but not including 0. So either you can say y is going to be greater than 0, or you can use your notation with your brackets. So then we are working with the reflection graph now. So this one, g of x, it's going to be the same idea. We can't cross the 0 line, but it's going to be less than 0. It's got to be under the 0, less than, under, or from negative infinity to 0. Please, some of you tend to write your points like this. You'll say 0 to negative infinity. That is wrong. Must be the more negative first. Okay, negative infinity is a lot more negative than 0. Right. Then for f, they're asking us to determine the coordinates of A, B, and C. So you really actually only have to work out the coordinates of A if you don't know your standard graphs. So coordinate A is the x-intercept of our log graph. So our log graph is y equals log 4x. So for an x-intercept, you make y equal to 0. And to get x by itself, we change into exponential form. We'll keep the base the same, get x by itself, and then let the 0 join the 4. So that becomes 4 to the power 0 is 1, so x is 1. That's where they've gotten that point, 1 and 0 over here. Alright. And then for its inverse, remember we just switched the x to y. So if it was 1 and 0, it becomes 0 and 1. And then for your reflection in your x-axis, remember just your y changes value. So from 0 to 1, it reflects, it becomes 0 to negative 1. Then for question G is the ones that you tend to battle with a little bit. So hopefully I can just help clear up what they're asking for. It says for which values of x is f of x less than 0. Less than 0 means that you're looking at under the x-axis. All right, so we don't want on because it's not equal to. If they wanted it on, they would have put an equal to sign. So let's have a look. Our green graph is the f graph. So here is where it interacts with the x-axis. And where is it below? It's going to be below for this portion here. So between x is 0 and x is 1. Not including 0 because it's the asymptote. Not including 1 because that's on the x-axis. Right, so it's got to be from 0 to 1. You could also have it as brackets. All right. So then moving on to question 2. Where is g of x greater than or equal to negative 1? So g of x is your red graph. All right, so where's your g of x greater than or equal to negative 1? Here's negative 1. So greater than means above or on it or equal to. So where's it above? It's this little portion here, but up to the asymptote where the graph can't cut. So we are working with the entire portion here, and it's going to keep carrying on. It's never going to cut that x-axis, but it's always going to be above that line, negative 1, if we were to actually draw in where negative 1 is. So it's from that point where x is 0 all the way to negative infinity. So either you can have it as x is less than or equal to 0, or you could have it as x is an element from negative infinity to 0, square brackets. Infinity is always round brackets. Then for question 3, it says, where will our inverse graph, our blue graph, be less than 8? Now this one's tricky because you've got to realize that they've given you some information, but on the original graph. So the original graph had your 8 and 3 over 2. So now on your inverse, that's going to be 3 over 2 and 8. So that's where they're suddenly getting the 8 from, because this is representing a y value. Where is your y value going to be? Less than 8 for that blue graph. Let's get it back in. Right, so where's your y value going to be less than 8? So there's 8. That's your point. So it's going to be less than 8 for that portion and for the rest of infinity. So now we just got to mark off what those values are going to be. So we have our x value that this point starts at, where the graph starts to go underneath. That is 3/2. Okay, 1.5. So we have the 3/2. Let's just get this all back. There we go. It's a bit neater. So we have the 3/2 and the 8. So below that point, so that must be our x value is 3/2, and then it's all the x values to negative infinity. So when we're looking at this, it must be that x is less than 3/2, and it's always the x values we're looking at. That's what the question wants to know, because they're saying for a y value of less than 8. So we need the x value. Or you can write it in your notation of x as an element from negative infinity to 3/2, round bracket if there's no equal to sign. Then for question H, the last one, if the graph of y equals f of x plus t passes through the point 11 and 3/2, write down the value of t. So let's just bring back some of the information. So here is our original graph, and they told us that we had this point 8 and 3/2. Now they're saying to us this green graph, something's happened to it. Now instead of f of x, it's become f of x plus t, and its new coordinate is 11 and 3/2. So ask yourself, how did I get from 8 to 11? Because my 3/2 stayed the same. It means we've shifted the graph to the right. And when we shift to the right, and this is from 8 to 11 is 3, it means that we must have subtracted in our equation. So it would have been y equals log 4x was the original. Now it can be x minus 3 to shift to the right. What you could have also done, so if we just go back here, so they've just done the basic shift. So we could have had y equals our log base 4x plus t. We have y, x, and t are the unknown letters, so we can subs in a point, and the point they gave us was 3/2 for the y and 11 for the x. So then you're able to work out your base 4 to the power of 3/2 equals 11 plus t, and then so in your calculator you can take that across, and it would end up being that because the 4, remember 4 is 2 to the power of 2, our 2's cancel, minus 11, so that becomes 2 to the power of 3 is 8 minus 11, which is negative 3. So you can do it algebraically if you don't see the shift. All right, so it's just quicker and easier just to do it the shift way. All right, then you need to work on the exercise 3, please, the interpretation, and I think go through some past paper questions as well. There's a lot on the internet, and just try and practice some of these interpretive questions for the functions.